and good day, Algebra. We are covering CO19 today. And I was going to do this yesterday. I kind of waffled whether or not to just go with it. I decided to save it for today because admittedly, you are a little bit behind the eight ball when it comes to slope because it wasn't, you did slope, you looked at slope, you know what slope is, but maybe you know what slope is, maybe you don't. But it wasn't covered quite in depth as a regular pre-algebra class would. So we're going to start by defining linear function, okay, and then get into slope a little bit, and then get into what the whole purpose of the objective is. So we've talked about a function before, right? We had function notation. We looked at how you can tell whether or not a relation is a function. A linear function is a special type, right? Because if you were to flip back to CO17, where we were given coordinate planes and there was this graph, right? We said that was a function because if you were to put a bunch of vertical lines through it, it would only touch the graph once, okay? But that is not a linear function. Just by thinking of the word linear, what are you guessing a linear function is that makes it different from other functions such as that V shape there? Yeah? It is a function because it does have that linear function, so it is a function, but it's a special type.
Does it have like a different, if you put the line horizontally or like differently?
Nope. Ellen? That was a decent guess. Has to do with lines, okay? A linear function is a function, I got to calibrate here. Ooh. A function that is a straight line on a graph. And I'm going to calibrate while you jot that down. A function that is a straight line on a graph. There, now the rest of the lesson will be perfect. A function that is a straight line on a graph. Okay? So, the next key point here says every linear function will have slope. Okay? Which means if you read the overall objective, it says I can identify a linear function. What you're looking for is slope. If you can identify a slope, you know that that relation is going to be a linear function. If you've got a graph to look at, well, you're just looking at does it make a straight line or not, right? That's why you only have two graphs that we're going to go over here, because it's relatively easy to tell which one is a linear function and which one isn't, right? The one that makes a line, okay? So we're going to focus more on the function tables, and we're going to, okay, that's close enough. And we're going to look at, does that function table have a slope, right? And slope is basically, remember I said the rest of the lesson would be perfect? That was fun. Okay, slope is basically the rate at which a line moves across the coordinate plane. Okay, the rate at which a line moves across the coordinate plane. Again, the rate at which a line moves across the coordinate plane. Have you heard the phrase rise over run before? Yeah. What does the whole rise over run thing mean? I wasn't asking you, Max. Yeah, you can raise your hand next time. Go ahead.
It's like you count from two endpoints how high up the line goes, and then you cut.
Yeah, so the rise in rise over run refers to how far you can count vertically to get from one endpoint to the next, and the run is how far you can count horizontally. Okay, another. Is it the mouse? Is that the problem? Okay. Thank you. Another way to describe that is change in y over change in x. Have you heard slope defined as change in y over change in x before also? Okay. Because if you think about it, what's the vertical axis on a coordinate plane? It's the y-axis. So if you're counting the rise, you're looking for, what's that change vertically? What's the change in the y values? And then the run going horizontally across the x-axis, that's going to be the change in x. So today we're going to focus on identifying that change in y over change in x to determine if there is slope. Because if there's slope, then it is a linear function. Okay, line graph. Yeah, you said all the right words. Okay, so these function tables, I've added these little ears on each side here. What I'm looking for is, let's start with the change in y. Look at -3 to -1. What's that change? How do we get from -3 to -1, Aiden? Add 2. So I'm going to put a +2 next to -3 to -1. Now we look at -1 to +1. What's the change in y from -1 to +1? Damien? +2. Okay? And then finally, look at from 1 to 3. What's the change from 1 to 3? +2. Right? So if with our y values, anyway, we've got a constant change. Okay? +2, +2, +2. Now we go to the x values, and we kind of do the same thing here. What's the change from +1 to +2? +1. From 2 to 3? +1. From 3 to 4? +1. So if we look at the change in y over change in x, for every single one of these, we're going up 2, which we can just write as a +2 without the plus sign here, over 1. Right? The change in y is +2. The change in x is +1. This would be the slope. To where if we were to graph this on a coordinate plane, we could count up 2 and over 1, like you did last year probably, right? And go up the line using that slope. So, is there slope? Yes. Is this a linear function?
Yup.
Yes. I like yup better. Yup. Okay, we'll put that. All right. Let's take a look at let's go to, let's look at the next one. Okay. Identifying the change in y from 0 to 2, from 2 to 4, and from 4 to 6. From 0 to 2 is +2, 2 to 4 is +2, 4 to 6 is +2. Okay? Folks. Now we look at the change in x from 12 to 15 is +3, from 15 to 18, again, +3, and from 18 to 21, again, +3. Right? So the change in y for each of them is +2. The change in x for each of them is +3. So the rate at which this line moves across the coordinate plane, it's going at a rate of up 2 and over 3, up 2 over 3, up 2 over 3. So that is the slope. Is this a linear function? Yep, it is. Okay? Yep, it is. I'm going to give you the next 5 or 6 minutes to kind of work through this. I'm going to pause the video. If you come across a question, just save it. And when we get back, we'll talk about which ones were generally successful, which ones kind of tripped us up, and then we'll close the lesson after that. So until moments from now, if you're watching this on the YouTube, we'll see you. All right, and we are back. So which one of these, we've got 2 yups up here. Let's get a nope. Which one was a clear nope? Kind of no ifs, ands, or buts about it. Christopher? Second row, third one, okay? And this is clearly a nope because we actually used this graph as an example up at the top of the page. This is not a linear function because it's not a line, right? It's a v. And if we look at slope, this does not have slope because it starts going down 1 over 1, down 1 over 1, but then it changes to up 1 over 1, up 1 over 1, right? As we, on the left side of this, the slope is down 1 over 1, negative 1 over 1, but then on the right side, it's positive 1 over 1. Those are not the same. They're not the same rates. And we can see that it's not going to make a line because it doesn't, okay? So what table was a clear nope for you, Jack?
It was the third one.
Why was that a clear nope?
Because on the first side, the x side, it goes 5, 10, and 20, and 25.
Okay, so the change from 5 to 10 is plus 5, right? The change from 10 to 20 is plus 10, which is different, right? And then 20 to 25 is back to plus 5 again. Okay. Plus 8, not plus 6, plus 16, right?
Oh, I didn't see that.
And then plus 8 again. Okay? Did anybody put that this is a linear function? Anthony? Why did you put that it is a linear function?
I don't know.
Oh, okay. Did anyone put it as a linear function and know why they put it as a linear function? Damien? Okay. Well, what we're doing here, just to go back to what we're doing is we're looking for slope, right? And slope is the rate how a line moves across the corner plane, change in y over change in x. And this one is a little bit of a tricky one because as we look at the rate of how this line moves, the first rise over run is 8 over 5, yes? The second rise over run is 16 over 10. And the third rise over run is back to 8 over 5 again.
So it's not a linear function. So if it's not all the same number on both sides.
Rowan?
But isn't 16 over 10 the same as 8?
It is.
Oh, what? 1 million.
The rate 16/10 is the same as the rate 8/5. Just like the fraction 16/10 is equivalent to the fraction 8/5. So this function table does represent a linear function, okay? Because, folks, because the rate of change is the same. And the key word there is the rate of change, right? 16/10, that rate, that fraction is the same as 8/5. Would it be like me to put one like this on the test?
Yes.
Of course it would, okay? So you need to be aware. So often kids that are working through this quickly, they do the first one, they do the second one, say, oh, it's different. And they just put nope and they move on with their lives, okay? But looking at the three rates, you need to really work it out to the end. Okay, so what is there now? Maybe you're nervous to answer this. Is there another one that is a clear nope? Aiden? Second row, first one. Aiden says clear nope. Let's take a look. Our first change in y is plus 25. Then we have a plus 0. Then we have a minus 25. This is not looking very good as far as being a linear function here. Looking at our x's, from 100 to 200, we're going up 100. From 200 to 300, up 100. And from 300 to 400, up 100. So clearly, these are different, right, as far as numbers. We kind of fell into a trap with that one. So let's look at these rates individually. The first one is 25 over 100. The second one is 0 over 100. And the third one is a negative 25 over 100. Are those three rates the same? Not even close, right? 25 over 100. simplifies to be 1/4. 0 over 100 is 0. And negative 25 over 100 is negative 1/4. None of them are the same. Okay? So this would be a clear no. Arlene.
But on a graph, it would just be a line, a straight line vertically.
This would not be a straight line vertically. When you would get a straight line vertically is when your x values are all the same. Okay? Not like the rate of change, but your straight up x values. That would give you a vertical line. Okay? Other questions? Okay. How about the fourth one? Raise your hand if you say yay, linear function. Raise your hand if you say nay, not linear function. The first row, last one there. 2, 4, 8, 16. Most say nay. Let's take a look. Folks, Aiden. From 2 to 4 is +2. From 4 to 8 is +4. From 8 to 16 is +8. Okay? We can't assume it's a no based on this because we have seen before where we still get a linear function when we've got different numbers as we go up the y's. So let's look at the x's. From 7 to 11 is +4. 11 to 15 is +4. And 15 to 19 is +4. Raise your hand if you said yay and explain to me why you made that call. Jack, Vince? No one? Okay. Raise your hand if you said nay and can explain why it's not. Wyatt?
The 4 over 4 is a whole, and 8 over 4 is more than 1.
Yeah, exactly. Again, we can compare the individual rates, 2 over 4, 4 over 4, and 8 over 4, and we can see those are not the same. Okay, 2/4 is 1/2, 4/4 is a whole, as you said, and 8/4 is 2 wholes, 2 over 1, so that would be a nope as well. Okay, the last one, the very last one. Raise your hand if you said a yay for that one. About a third, about half of you? More than half now? Peer pressure, people are giving in. Raise their hands, okay? Raise your hand if you say nay, the last one is not a linear function. Nobody? Way to stand out in the crowd. Way to stand out. Let's take a look. Well, then you can't be wrong, right? Joey, what is the change in y from 50 to 29? Minus 21. How about from 29 to 8? Alexis, what's the change in y? From 29 to 8. Joey, you had your right. Minus 21. And how about from 8 to negative 13? Minus 21. Okay. Now we look at this. So far, this is looking pretty linear, right? Yeah. Okay. Taking a look at the x's now. From 9 to 16, +7. From 16 to 23, +7. And 23 to 30, +7. Will, what's the slope of this line here? Yep. Negative 21 over 7, which we could simplify to be negative 3 over 1, or just negative 3, right? Since it's a rate, we can treat it like a fraction. So is this a linear function? Yes, it is. Okay. And then obviously this one would be too, because it is a straight line on the corner plane. Alex? No. The question here wasn't what is the slope. It was, is it a linear function? We needed to determine if there was slope to say whether it was a linear function or not. But if I did ask you what is the slope, you would need to simplify. But that wasn't really the question. So if you didn't, that's okay. Max?
Never mind.
Rowan?
If the question was like, what is slope, and it's not a slope, what do you put down?
Then there isn't one. not a linear function. Alex, for the graph, the slope for this one, if we go from point to point, looks like it's up 1 over 2, up 1 over 2, and that pattern kind of continues throughout. If we read the graph from left to right, we're going up 1 over 2 to get from point to point. So the slope would be up 1 over 2, or 1/2. Okay? Questions on this? Sir? Quickly. Anything else? Okay, the two down at the bottom, you get to make your own function table that is a linear function. And it says the first one needs to have a slope of -2/7, which means that as you go through your x and y values, one of them will have to be going up, one of them will have to be going down, right? If they're both going up, that would be a +2/7. If they're both going down, a negative divided by a negative is also a positive, okay? So one's got to be going up and one's got to be going down. Does it matter which one goes up and which one goes down? No, because a change of y of down 2, a change of x of up 7 is the same value as a change of y of up 7 and a change of x as down 7, right? Those two fractions are the same thing. Okay, they're the same value. So it doesn't matter which one goes up and which one goes down, but one of them has to, not both. And then for the other one, linear function with a slope of 5/4. What are your options here as far as up and down? Both going up, both going down, one of each. What are your options, Ellen? Both going up or both going down, right? Because if both are going down, a -5 over -4 is equal to +5 over +4. Okay? Jack?
So does x on the bottom and y goes on the top?
Yes. Yes, the change in y or change in x, it's always y over x. Okay, slope is never x over y, always y over x. Other questions? What was that?
Does it matter which side of the table we put it?
It is much, much more common for your x variable to be on the left side of the table.
Well, I'm not common, so.
I encourage you to put your x variable on the left side of the table. Shh, Alex, warning for you. Or Damien, whoever's chatting. Both of you probably. Okay? Questions, comments, concerns, complaints, compliments, congratulations, or criticisms?
Thank you.
You're welcome. Yes, sir.
Oh, what's your time?
Oh, so 2 years ago, one of my students brought me a box of like 100 ties and said my parents were going to give this to Goodwill, but I thought you would like them instead. So this is from her collection. I've been trying to find a shirt all year that would kind of match it. I don't think I found it yet, but I just went with this today because, yeah, I don't know. I feel like it'd be like a clown tie, maybe like 2 inches wider, but anyway. It's, well, I don't know. It's supposed to be circles, or kind of like circles, blobs. I don't know if it's supposed to be anything in particular. But this is due tomorrow. Tomorrow feels like a great day to play the number game, considering we went through most of it together in class. So help each other out. Make sure your friends are getting their homework done. And that is how you math.